पे तो वो कुछ 15 kg ना?
Yes, sir. For
Yes,
student,
so that
it is
there's a
25.
student allowance.
हाँ, then that is better. वो आजकल हार्ड केस बैग आते हैं, हार्ड केस बैग का ऐसे ही वजन हो जाता है 5 kilos, so it becomes a problem. Anyways, so I think we are expecting more people, if I'm not mistaken, right?
Yes, sir.
Okay. So what we will do is we will just wait for some time before others join, and meanwhile we will just. By the way, I'm Sujit. I'll be responsible for helping you learn ship construction in this semester. And just a minute. Totally, you all are 40, which means we are expecting, okay, almost half of the students are not there. Today is the first day, we will wait. Mm, Okay, so I think we have waited enough. Am I audible to you?
Yes, sir. Good morning, sir.
Okay, good morning. So 10 of you were there. I just told you, like, my name is Sujit, and I will be helping you learn ship construction. Without further delay, let's start. And before I start, I just want to, this is the first class, I want to clear out a few things. Please let me know who is your CR. Has it been decided yet?
No, sir.
Oh, okay. And when is that going to happen?
In the campus only, sir.
Yes, sir.
Oh,
Probably when we report to the campus on 20th.
okay, no problem then. In that
Till
case,
then, we have a previous CR of semester one, Sumit.
no worries. I'll
Sumit
just
Joshi.
no, that is okay. I'll just share my number with you. So whenever your CR is decided, please, drop me a message. Not preferably on WhatsApp. I don't use WhatsApp. You can just drop me a SMS or give me a call. That would be good enough. Okay.
Okay, sir.
I'm just sharing my number with you. Okay. I hope you all have got it. Now, regarding attendance, this is something we need to finalize as to how we are going to take that. You want me to call your names individually, or will you be comfortable if your CR just tells me, these all people are absent and I'll be marking them absent?
Sir,
How do you
second
like that?
option.
Second option, no? I also like that. We will be wasting less time. So, in the meanwhile, whoever your CR was in the previous sem, can you tell me the numbers who are absent as of now, today?
Sir, I will check and let you know, sir.
Acha, ha. See, do that. And before the end of the class, 5 minutes prior to that, just let me know. Okay.
Okay, sir.
Yes, this is for today only, but usually what we will do is we'll be taking classes in the attendance in the beginning itself. Otherwise, I had a bad experience in the previous semester. So with that, uh, I just want to ask a few casual questions, nothing serious. How was your exam? How was your final semester?
It was good, sir.
It
Good,
was
sir.
good.
It went great.
Okay. So the thing is, it went good because you all were actually ready, or it went well because it was online exam?
50-50.
50-50. Okay, that was an honest answer. I like that. Now, what I would like to say is, this is just a suggestion. I mean, you all are in a field where your exams are not getting over in the college itself. Okay, so once you move out to your jobs, also you'll be requiring to clear quite a few exams, competency exams, to get your promotions, kind of thing. So what I would suggest is, if you have missed out on any topics in the this ship construction and stability one, I will be more than happy to clear it off in this semester itself if you have those questions. Okay. And what I would like to say is, while you are in college, while you are a student, make the most use of it. At least keep collecting the materials, books, whatever is required for you to learn. Because once you pass out, you won't be having this environment of, reading and shooting a question wherever you want. As of now, you can call me anytime, and you can, not anytime, not exactly 9, 12 o'clock, but you can call me and ask questions. But after you pass out, that becomes difficult. So make use of that, and it will be good to go. Thirdly, uh, we will have a look at your syllabus. Just let me know, have you studied anything about loads on ship structures in the previous semester? Have you studied that? Or was my question not understandable? If not, I will repeat.
So we have studied load lines.
Load lines. Okay. So you're not aware of. I mean, basically, it means what are the different types of forces, that act on the ship while it is in the sea. Of course, it is a natural environment, so there will be some forces, unwanted forces acting on it. Okay, we will start from there itself. Uh, the second thing is, for your from your classes point of view, uh, I was thinking of your evaluation, your continuous evaluation. What we will do is we will be having quite a few questions in every class. What I mean is the PPTs that I will be sharing with you. I will start sharing with you those PPTs from Monday. Every class we will try to have quite a few questions. That means a small objective type questions. And I just want you to know that please do not answer them as and when. You have a option in Zoom to raise hand. Are you aware of it?
Yes, sir.
Yes, sir.
Okay. So I would really love if you use that function to, kind of raise your hands whenever that situation comes, to maybe ask a question or to answer a question. And I mean, that way we will have a sensible classroom. Okay. Instead of everyone shouting at the same time, we can have a meaningful discussion. Okay. These are the ground level rules that we will be following for this semester in this subject. Now, uh, let me give you a brief overview of what we are going to see in this semester. Okay, I will tell that in say 10 minutes, and then we will move on to our actual subject. Let me just tell you that, and we will be good to go. Okay. Let me share the screen. Okay, so this is just a blank sheet that I could find, and what I want to do is just a minute. Okay. Is my screen still visible to you? Whatever I'm sharing?
No, sir.
No, sir.
Okay, I have some technical issue then. Just a minute. Okay, just a minute. That first class, that technical issue will stay a little bit, but do not worry about it. It's still showing me that I'm sharing the screen. That is why I'm worried. Just a minute. No, it's not holding up. Okay. Just a minute. Okay. For some reason, it's not working. It is still showing me that I'm sharing the screen. What should we do? Okay, let's not waste time on this. Let's jump into the topic, and there itself I will try to clear this thing up. Maybe I need to update my system. Right. Okay. Okay, is it visible now? Is it?
No, sir.
Still not visible. Why is this happening? Just a minute. It says unable to connect for some reason. Okay. Wait. This is not normal actually. Wait, let me use a cable then. Maybe I'll be able to do that way. Okay. Okay. Let me try it this way. If it works. Is it visible now?
Yes, sir.
Yes.
Okay. Okay. Maybe there is some issue with network. So actually the first unit that we will be talking about is it's related to framing of ships. Okay. Now, basically what we are going to see in this subject, let me tell you that is not difficult at all. It is quite easy to understand. God, what is that sound? Are you able to hear me?
Yes, sir.
Yes, sir.
Loudly.
Yes, sir.
Okay. So this ship construction, let me give you an overview that ship construction nowadays is being done by naval architects, but naval architecture is relatively a new field of engineering. Many universities, they have it in their mechanical department itself. Okay. What I'm trying to say is, most of the things that you're going to learn in ship construction, they are very logical in nature. That is no rocket science. We can relate it to different day-to-day, scenarios and objects, and maybe we can derive some better understanding out of it. Now, your first unit, it deals with basically something called as framing system. And this framing system basically means how do you strengthen the structure of the ship. Okay. Now, think of it this way, that if you want to make a chair, say for example, okay, if you are tasked to make a chair, the first thing that you would like to know is what are we strengthening it against? That means what is the intended use of that chair, isn't it? You need to know what is the magnitude of forces that will be acting on this chair, and accordingly we will make it strong, right? So similarly, when we are talking about strengthening the ship's structure, we need to be aware of what are the different types of forces that the ship may experience. And what are we strengthening it against? Okay, so keeping that in point, we will move on to understand stresses in substructure. First of all, these are some basic definitions. Are you aware of these 6 degrees of freedom? If yes, I will just skip because this is not in your syllabus. This is just an introductory class. Are you aware of it? Do you want me to cover it again?
Sir, only few are be aware of.
Okay.
Yes, sir. Few of
No
them.
worries.
Ruling, pitching, and leading.
Okay. We will understand that as of now because these definitions we will be using it on a daily basis almost. So you need to be aware of that. See, what this basically means is, in what all manner the ship can have motions. Okay. By that, what I'm referring to is, there are 6 degrees of freedom. Any body in this universe in which we are living, it can have at most 6 degrees of freedom. We have 3 different axes, X, Y, Z. about every axis, the ship can have a translatory motion and one rotational motion. So totally we have 6 degrees of freedom. Okay. Now let's understand this. The ship can possibly jump up and down in water. Am I right?
Yes, sir.
Yes. So that is what we call as heaving. Okay. Similarly, let's not use pink, let's use blue. Similarly, we have another motion. This is also a translatory motion. Please understand these are along the axis. Okay. Translatory motions are the motions which happen along the axis, not about the axis. Okay. So that previously what we are seeing here, this is a translatory motion about the z axis. That means the ship is jumping up and down kind of. And here the ship is having a motion along the x-axis that we are calling as surge. So many times you will see that people, they say, the ship is surging ahead. Instead of saying the ship is moving ahead, they say the ship is surging ahead. That is because this degree of motion of the ship, that is about the length of the ship, it is called as surging. Okay. Now we talked about Z. This is the x-axis. Similarly, in the y-axis, also the ship can have a motion. Now this also happens because of it cannot be, not cannot be, it most of the time it will not be an isolated motion. That means there will be some other motion also associated with it because of the massive size of the ship. But the translatory motion of the ship in the y-axis is called as sway. Okay. Now, these three, what we saw, are the 3 translatory degrees of motion. Similarly, we have pitching. Can you tell me this motion is about which axis? X, Y, or Z?
Z.
Z? Any other guesses, maybe? Or everyone
X.
agrees?
X.
X. Okay.
Yes, sir.
We are left with only one more option. Anyone wants to try that?
Y.
Okay. So that was a wild guess, or did you think about it? Now, the answer to this is actually Y, which came in last. Let me explain. Dekhiye, when I'm saying that it is about which axis, that means, think of it, we have a axis right here. Okay. If I put a stick through that axis and I roll it from either side of the ship, don't you think we will have this motion?
Yes, sir.
Yes, sir.
Yes. Now, for the people who said z-axis in the beginning, let me explain. When you are looking from the z-axis, you'll be seeing the plan view of the ship, something like this. Okay. And you have an axis through this, isn't it? So if I imagine this to be a small toy, I put a stick through that, I catch it from both the ends, that is under the ship and above the ship, and I roll it. Don't you think the motion will be like this? Are you getting? Or do you want me to say again? Tell me.
The Z axis
Could
is
you
not for
could you
3D
repeat that?
object.
Sir, say it again.
क्या हुआ जी?
So could you repeat the last point?
हाँ, sure. देखिए, when we are talking about rotational motion about the axis, okay? See, when I'm talking about motion about the z-axis, that means I'll be seeing the plan view of the ship, and the z-axis is passing through this point itself, isn't it? Right?
Yes, sir.
Yes. So when the motion is happening about that axis, that means imagine it like this. Like I put a stick through that particular point, and I, kind of roll that stick. The stick will be under the ship and above the ship. If I roll that, I'll be getting a motion in this direction, isn't it?
Yes, sir.
Yes, sir.
Yes. Now this is the motion about the z-axis. Did you understand why pitch is a motion about the y-axis? Clear?
Yes, sir.
Yes,
Okay.
sir.
Similarly, this is yaw. Okay, this is the motion about the z-axis which passes through this. This is the plan view of the ship. Okay, and finally we have the roll. Okay, this term you must have heard, come across, most widely used. Now, a rolling, this is about which axis? Tell me.
X.
X.
Yes, very good.
X.
This is the x-axis, the length of the ship. About that, when it is happening, we call it as rolling. Okay, these are the three rotational degrees of motion, and earlier what we saw, they were the three translatory degrees of motion. Okay, why we learned about this is because many a times, purely because of these degrees of motion, also there can be certain forces that will be acting on the ship's structure. Okay, so we need to know in what manner the ship is going to behave in the environment for which we are making it, and we need to know what are the different types of forces or what are the different types of situations that the ship may experience when we put it in that particular environment. Okay, so let's move on to different types of stresses. This is a diagrammatic representation of what we just saw. Okay, do you have any questions on this, or should I move? Okay, Mr. Sumit
So you
says
can move
that.
forward.
Okay, all numbers are jumbled up. No worries then. What I will do is 10 minutes prior to the end of the class, I will just call up your numbers and I'll take the attendance. Not to worry, you focus on the class. Now, coming to different types of stresses on the structure of the ship. These stresses that happen on the structure of the ship, very often we can classify them into a number of categories. Okay, now to classify them, we can broadly we can classify them into local loads and global loads. Let me give you an example of local and global load. Suppose I have a vessel. Now in the vessel, I have those compartments. Now in the compartment, I may have, suppose I'm carrying iron ore in the vessel. Okay, so I have iron ore here. Now purely because of the mass of this cargo, this particular structure or this particular deck will be under some stresses, right? Are you getting my point? That
Yes,
is a
sir.
local load. Okay, that is a local load. Now imagine our ship was moving in water happily. The ship was in calm water, and suddenly, because of the waves and everything, or maybe because of say for example, improper loading of the ship also, maybe because of that, what will happen is, if in this, if I have cargo here and I have cargo here, because we have improper distribution of cargo weights, our ship may try to bend in this manner. Now, this particular example gives us a view of having a local load in that particular region, and because of that local load, the ship is experiencing a global load. Okay, is it clear? Clear? Yes or no?
Yes, sir.
Okay. Now, these local loads can be because of a number of factors. Okay, it may be because of fluid pressures. I mean, like cargo maybe, or different fluids in the tanks, or it may be because of heavy machinery. Heavy machinery, matlab, it can be cranes, or in case of say defense vessels, they have those gun mounts, those missile mounts, all these things. Basically, any abnormal amount of weight in a smaller region, when it is concentrated there, that becomes a local load. Okay, we will understand later what do we do in this case, because what happens is the contact area, it matters a lot. Whenever we talk about a material, we say that it will be capable of taking this much kilonewton of force per meter square, isn't it? This is how we define, right? How much pressure it can take. So if, okay, we have a chat. In terms of merchant ship, what can be a local load? It can be these cranes. It can be cranes. In case of oil tankers, you will have those hose handling cranes. I will show you those things. On almost every ship, we have those cranes or davits. Now they are local loads. Okay, because compared to the other portion of the deck, the portion of deck which supports these decks, I mean these cranes, is quite small and they are under immense pressure. And because of that, we have to make some modifications. We have to adopt certain changes to the structural design compared to the other parts of the ship. Okay, maybe we will try to thicken the plating of steel under that crane, or maybe we will want to add an additional steel plate under that crane foundation or something. We will slowly build up our pace and we will understand those things. Okay, these are examples of local loads. Now, one more local load is panting. Panting means what happens is the water, let me explain it this manner. This is the bow of the vessel. Now, the bow of the vessel can or is subjected to two loads. These load, I mean these waves, whenever there is a crest, that means the crest kind of hits a portion of the shell of the ship, and next when we have a trough, that portion is not under a stress. What I am trying to say is the shell plating of the ship will kind of move in a in and out manner because of the crest hitting it, or a larger wave hitting it. It may try to kind of move inward, and when that force is taken out, it will try to kind of normalize itself by moving slightly outward. Are you getting what I'm trying to say?
No, sir.
No. Okay. देखिए, think of it this manner. Okay, let me remove this. Okay, I have a vessel. The vessel is under a crest, and sometimes it is in a trough. Whenever, think of a small plate, जो tin plates आते हैं ना, those tin plates, you will see those tin plates or those plates even, the plates which they serve you in those restaurants, if they are metal ones. I mean, in restaurants they don't give metal plates, but in small shops, cafes, you can push that plate a little below, and when you leave your pressure, it kind of pops out. Have you noticed that anytime? Maybe.
Yes, sir.
Yes, sir.
Yes. Similarly, the shell plating of the ship, when a wave crest hits it, that means there is some greater force acting on it, because of which the shell plating may slightly move inward, slightly. Okay. And when the next moment the crest has passed, a trough has come, that force which was acting on it, it has been slightly reduced. Because of that reduction in force, the shell will again try to ease up by coming to its normal position. So it is a rhythmic in and out motion of the shell plating. Is it clear now?
Yes, sir.
Yes. Now this particular phenomenon is called as panting. Now this panting, though it may sound like it is a minor force, it is not. When we talk about the inner structure of the fore end part of the ship, I will tell you what kind of structural measures we take in order to withstand these panting forces. This picture is kind of a representation of the kind of damage that panting can cause to a ship structure, and it is quite severe. Okay. Next, we come on to pounding. Pounding basically means, many a times in videos, you will see that, a ship will kind of climb on a wave, and then the bottom portion of the ship will kind of slam against the water. It will kind of hit against the water. Have you seen anything like that? Can you imagine
Yes.
it? Yes. This kind of force is kind of, you can relate it to. Have you ever done swimming anytime?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
The swimming pool may, like when we used to do that, our friends used to fool someone. They will say, can you slap water? Have you done that? Tried to slap water?
Very painful.
Yes, sir.
Yes,
Very
sir.
painful. Exactly that kind of painful is pounding for the ship. The ship kind of climbs on a wave and hits its surface, the bottom surface, against the water. That is called as pounding. Okay. Now, panting and pounding, they are localized in nature. Okay. Now think of it. Uh, when you hit or slap the water with your palm facing the water, then it is painful. But if you kind of hit water sideways, I mean, the way they do in karate, right? If you do that way, will it be very painful?
No, sir.
No, sir.
No. So probably we can think of relating that with this, and we can say that the more the contact surface area with water, the more it is painful, isn't it?
Yes, sir.
So if we can try to reduce the contact surface area to some extent, maybe we will be able to reduce these forces. Am I right?
Yes, sir.
Yes, sir.
Which is why you will see in many ships, when you see from forward, the structure of the ship will be kind of like this. Have you seen?
Yes, sir.
They will be kind of spreading out. Now, this kind of a design feature for the ship is called as a flare. Now, this flare is not a very it's not like very good thing. It has its own disadvantages also, because when we have a relatively sharper structure in the water, basically what will happen is more amount or more portion of the ship will go into water, isn't it? जैसे if you hit the water with your palm facing water, your water will not go deep into water. But if you do that karate wala strike, your water will go into water much deeper. Am I right?
Yes, sir.
Yes, sir.
So similarly, when we have flare, we are reducing those pounding forces. But because of that, more portion of the ship will try to, kind of go into water, and we will have open seas coming onto the deck of the ship. Can you imagine that?
Yes, sir.
Yes. So this is something, I'm just slightly trying to relate, what kind of forces act and what kind of steps we can take after understanding those forces. So similarly, here also, because of panting, what we can probably do is, we will see that later, but still, if we can kind of, connect some beams or some structures in this manner, then probably that plating will not be able to move in and out that much, because we have supporting structures inside. But to be able to come to this conclusion that we may add these types of structures inside the ship, we needed to understand what are the forces, and because of that force, how is the structure going to react. Okay, so similarly, I will move quite a little fast now, because we need to complete quite a few things. So the third one is grounding or dry docking. Now, because of grounding or dry docking, basically what happens is when you kind of dry dock a ship, dry dock means just say you have a vehicle or a car, you take it to your showroom for your servicing. Similarly, uh, a ship has to be taken kind of for servicing, for different works to be carried out on it, and that we call as a dry dock. In a dry dock, what we do is we take the ship inside the dry dock, and then we kind of start pumping out the water. As the water is pumped out, the vessel will start slowly moving down until it sits on these blocks. These blocks are called as keel blocks. We will come to that slowly. But why this portion is kind of moving down? The reason for that is in an empty ship, the aft portion of the ship is heavier than the forward portion of the ship. Because in the aft portion, we have the main engine and all the associated propulsion equipments. Because of that, when this water is pumped out, basically the buoyancy force reduces. And because of this reduction in buoyancy force, the aft portion will try to move downwards a little faster. And that may hit the keel blocks with a little impact and a little sooner than the forward portion. Am I clear on this? Is it understandable?
Yes, sir.
Okay. So this is one more, and we will see when we talk about bottom structure, we will see what kind of precaution we are taking against it. Okay. Yes, this is the other type. This is called as the vibrational loads. These vibrational loads are mostly because of the equipments when they are moving. You must have seen in your houses you will have those water pumps running, right? When that water pump runs, you will see that it will be vibrating quite a lot. Am I right?
Yes, sir.
Yes,
Huh.
sir.
Now, if you try to, put your hand on that, or you try to keep a paper, and on the paper you kind of keep some grains, they will shake and they will kind of fall down. Now, you also must have read about something called as resonance. Am I right? Do you know what is resonance? Matlab, there are two bodies close by, both the bodies vibration frequency, if it matches, then the total frequency can kind of move, can skyrocket, and the structures may fail. Have you ever heard of it? Resonance?
Yes, so the amplitude might increase.
Exactly, yes. So because of this, just a minute, I'm getting a call from college. Yes. So there are these vibrational loads also. Now, these vibrational loads are not that easy to kind of say that, against this, we can take this kind of a precaution. But one very important or one very common practice of dealing with vibrational loads is using rubber pads. Matlab, if you put vibration against a rigid body, that may fracture. But if you put vibration against a rubber mat or something, which is slightly able to take those vibrations, then that is a good practice. Okay, so that is what we do, and we will see that little more detail later. Now coming to global loads, this is where the real thing happens. Okay, first thing, one type of global load is hydrostatic pressure. This hydrostatic pressure means you must be knowing that the deeper you go into water, the water pressure increases. Am I right?
Yes, sir.
Yes.
Yes, sir.
So in the picture, what I have tried to show is a hull of the ship, and the red arrows are the hydrostatic pressures acting on the hull of the ship. And the dotted lines, they kind of represent the manner in which these forces are trying to, distort the hull of the ship. Okay. Now, these forces will obviously be more, or they will be more prominent on the bottom shell of the ship because it is at a greater depth compared to these portions. Am I right?
Yes, sir.
Yes. So in this case, because we have the hull like this and it is kind of bending in this manner, maybe we will try to put some some plating kind of thing maybe in this manner. If we put, maybe it will try to resist this deformation or maybe this distortion from the forces. Don't you think we can do that, something like that?
Yes, sir.
Yes.
Yes.
So we will see in more detail later. I'm just now, later on we will see how such a structure will be added, and if we add a structure like this, how do we support this structure, how do we fix it, how do we strengthen that structure. We will see a little later, maybe next week. Okay, on Monday we will see. Yes, on Monday we have a class. On Monday we have two classes actually. In one day we have two classes. Okay, so the second thing is racking. Racking means, uh, think of, the ship was stable in calm sea. Suddenly, a huge wave came and hit the ship. Now, because of that, what will happen is, because we have some portion of ship inside the water, I mean, here the behavior is because of the fluid. Try to understand. If I had land, on land, if I have a box and someone hits it, maybe the box will just topple over. It will just fall. Maybe, isn't it?
Yes,
When it
sir.
is in water, this
Yes, sir.
portion is in water. So water is a viscous medium. So water has its own resistance to motion. Okay. In this case, the resistance to motion is only inertia and friction. That's it. In this case, it is the friction, it is the inertia, plus it is the viscosity of water, which is resisting the motion of that ship. When a wave hits, what will happen is the side shell this side shell will try to move in this manner, but more dangerous effect will happen with the deck because the deck will kind of try to slide off from its position. So, in short, what this particular phenomenon tells us is we need to provide special attention to kind of secure the deck with the side shell. Am I right? Is this understandable?
Yes, sir.
Okay.
Yes, sir.
Now, to give you a little perspective of what we are talking about, you all must have seen small tables or small stools, which will be made up of this design. Please see. This will be the top plate of the table or the little stool that you have. The legs will be something like this. So you can sit on it. This is a small stool. Now, in this kind of designs, what you will notice is they will have a little plate which will be welded like this. Have you noticed this?
Yes, sir.
Now,
Yes,
this
sir.
bracket is essentially doing the same thing what we are talking about here. It is kind of a kind of binding the top plate and the legs together so that whenever you sit and you kind of roll in this manner, the top plate does not get separated from the legs, right? So similarly, when we are strengthening the structure of a ship, we need to kind of put something like this inside the ship. We have to probably add some additional structures to increase the bonding between the deck and the side shell. Okay. Now, this is just a picture of how severe the environment can be and how probable or how likely racking forces are in the practical scenario. Okay. Now, come to torsion forces. Now, torsion forces are slightly difficult to explain in 2D, but still, mm, what it happens or how it happens is imagine how to say this. How to say this? Okay, let's see this. Suppose uh, I have a speed breaker here on the roads. Okay, imagine on the road we all are very angry on speed breakers because they slow us down and sometimes you'll find quite a few speed breakers. Now you must be aware that there are 2 3 different types of people. I mean, the way they approach these speed breakers, some people are those hero kinds who don't even slow down. They will come, they will kind of stand on their bike, they will jump and they will go. Have you seen that?
Yes, sir.
Some people will slow
Yes,
down
sir.
and they will go on the speed breaker. There are the third type of people who don't follow either of these rules. What they will do is the road is like this, but they will not go like that. Instead, they will take a diagonal way. They will kind of slowly glide onto it and they will go. Have you noticed that? Have you tried that?
Yes, sir.
Now, when this
Yes,
kind
sir.
of a thing happens, what happens is basically your front part of the bike has covered the speed breaker, and the back side of the bike is still behind. Okay, in case of bike, this example is not very suitable because the front tire and back tire, they have a gap in between. But in case of the ship, imagine this kind of a motion. The front part has already climbed a train of waves. These blues are the crests, these red are the troughs. So when the a portion of the ship has already crossed a wave and the other portion is crossing, the hull of the ship will slightly be twisted in a direction. Can you imagine that? Because of that, that partial movement of the ship through a train of waves, the front part will be slightly twisted compared to the aft part of the ship. Is it clear? Or is it difficult to understand?
Yes, sir, it's clear.
Okay. Now, this kind of loads are called as torsional loads. Okay. I think we will stop here. Hogging and sagging, we will see a little later because I need to take the attendance and we need to see. We don't have the attendance data. Okay. We will stop here. And let me just note down that, wait, NS2, we will be starting with hogging and sagging. Okay. Okay, so this is where we stop. And coming to the attendance part, let me stop sharing this because, okay, I'll just remove this. Quickly, please tell me 0041, are you present?
Sir, he was present, but he had some network issues.
Okay, he was present. Okay, ठीक है. 042. Absent? Okay, absent. 43. Do you want to see the attendance? I have barely 1 minute, so please. Why is this Zoom misbehaving? Let me try to share the screen. Okay, this one. Quickly, moving on to 43. Absent. 44. Absent. 45.
Present, sir.
Okay. 46.
Present,
Absent.
sir.
47.
So 46 present.
Acha, present. Okay.
So 44 present
Okay.
too. I couldn't unmute on time.
Okay, ठीक है. Present. Okay, 47. 47 be absent. Okay. 48. Absent. 49.
Sir, 45 present.
Yeah, 45 is anyway present. No worries. जहाँ पे A लिखा है, only they are absent. 9 o'clock I have another class. 49.
Present, sir.
50. 51. 52. Anyone is absent, just tell me. I have to go actually. How? I mean, at any point of time, where all the people present, just tell me yes or no. Any point of time, always present.
No, sir.
अरे yes बोल देते. ठीक है.
Yes, sir, all are present, sir.
Yes, sir.
Sometime they all were present, right?
Yes, sir.
Yes, sir.
Yes.
Yes,
Okay.
yes.
At the starting
All
of the
present.
class, all were present.
All.
Okay. Okay. Then all present for today. No
Yes.
worries. I'll just make these all present. But next class, be careful. Okay.
Okay.
So this is done. Okay. I'll see you again on Monday. Okay.
Thank you, sir.
Chalo. Have a good day. Take care. Bye.
Bye, sir.
Bye, sir. Thank you, sir.
Okay. Bye.